So basically, I've been experimenting with the various Bedini circuits for his radiant energy charging, and I was specifically interested in his SCR diode dump method right here, or like where he uses the SCR to dump the capacitor at a given voltage into the battery. I wanted to do that myself, so this is my variation. I had to figure out a little bit, the pin out of what I was using here. But I figured it out, and sure enough, this is what I came up with. I've got this box here I built, which I call my reactance box, and it limits the current of the AC. So I'm actually plugged in directly to the AC down here, right into this thing. So it's 60 hertz. I have a rectifier in here without the filter cap. To keep this 60 hertz, we want the pulse. And this is the cap which brings down the amperage. I want to limit the current without actually causing resistance, without having to pay for it. No loss in heat. So I bring it down to 50 milliamps roughly this way. And the SCR is over here connected, and what it does is it's connected to this capacitor here, which is 250 volts, 47 UF, and it's charging off the DC spikes at 60 hertz. And when it reaches around 100 volts, it triggers the neon. You can hear it and see it flashing there. That's about 100 volts every time that triggers. And that goes into the charging battery right here. And now if we look at the meter, we're getting a charge from this. I can hold the meter. It's always difficult with the camera at the same time. Live. So here we go. So now we're at 11.67, and it usually rises slowly, and this was a dead battery, like completely dead, and I think you've seen it there flick at 11.68. So that's what it does. It slowly rises and is getting a dump from the capacitor at about I'm not sure if it's 100 volts or 56, something like that. So the way the neon works, it triggers at around, I know at around 100 volts, then it pulses the capacitor into the battery. And this one here is basically charging my battery, and the capacitor here, essentially for free or very little, fractions of a penny. So very, very efficient that you could use this as real current after.